In this video, we're going to look at designing a catapult in Autodesk Fusion. Let's go ahead and open a new design, and we'll go to Hybrid, Create New. I've already come up with my concept and ensured that it's going to fit within the 8-foot 2x4 that I'm constrained to. But after we design all the components and assemble them here in the workspace, we'll use Fusion to lay out each one of the components and verify once again that we're going to be able to get all the cuts that we need out of our 8-foot 2x4. So let's start with our base piece. Make sure that you have the entire assembly activated. First, let's go ahead and save this. I'm going to make a new folder. Sorry, I'm going to make a new project. And I'm going to save it within this project. Make sure the entire assembly is activated. Add a new component. This will be my base piece. Let's open a sketch. Now, in an effort to conserve material, I'm going to cut my 2x4 in half along its depth, meaning I'll open a sketch on the front plane right here. Draw a rectangle anchored at the origin. Now a 2x4 actually measures 3.5 by 1.5 inches. So I'm going to go 1.5 up by 3.5 divided by 2. Fusion will do the math for you. 1.75. Now I also need to account for the fact that I have an 1/8 inch kerf, meaning 1/8 inch thickness of the cut anytime that I use a saw. So what I'm actually going to do here is, instead of 1.75, which would be 3.5 divided by 2, I'm going to make it an 1/8 inch less than that, which is going to be 1 5/8. So 1.625. Here's my cross section. And I'm going to extrude this a distance of 18 inches. Add a material. We're just going to go ahead and use pine for everything for this project. There's my first base piece. And what I can do next is activate the entire assembly, click on the base, Control-C, Control-V, and I'm going to position this piece (18 inches) behind the existing one. Now let's just make sure that's exactly 18 inches away, because you might recall that now it's going to be 18 inches from front to back. So I actually do want to move this. It doesn't matter. We'd be able to move it when we go to assemble everything anyways. I got to unground this from the parent in order to move it. I want to select components. Now this has to go 1 5/8 that way. Now my front to my back, if I hold Control here, is 18 inches. That's what we want. Let's go back to our home view. Okay, there are our two base pieces. Next, we have to add the two cross pieces to our base. And in fact, these are going to be nearly identical, but they're going to have holes in them for our dowel rod. Let's start by adding our dowel. Another constraint that everybody's going to have is that they're going to be given a dowel rod for their shaft that measures 1 inch by 1 inch diameter by 6 inch depth. It's going to be the same material. Now this is probably going to be a major constraint on us. This is really going to dictate how close the stance or how narrow the stance of our catapult needs to be, if you will. So what I'm going to do next is I'm going to draw the two base pieces that run along this way and this way. And we might find that we can conserve material by making these other base pieces shorter. I'm going to go ahead and use my handy dandy project tool. Project this corner right here. Select OK. 2-point rectangle. And the dimensions are going to be exactly the same. 1.5. The cross-sectional dimension is by 1 5/8. Extrude. Let's go a distance of 18 inches. Whoops. I made a classic mistake. What did I do here? I made this body part of the shaft. So I'm going to delete that. Go up here and activate my assembly. New component. I'm actually going to change I'll call these feet instead, or I'll call it a foot. Back to my project tool. And I'm just noticing I gotta redefine my sketch plane here. So right click, redefine sketch plane, put it on this face right here. That's what we want. What happened here? The distance from here to here, did these move on me? Activate the assembly. Move it 1 5/8. There we go. That's what we want. Our foot, right click, add a new material. Boom. There we go. Here's what I'll do. I'm actually going to change this. Go to activate the component and I'll show you why. Instead of defining the distance, we can use a parametric feature in which we say that we want this to extend to an object, which is going to be the back of this face right here. And we'll hit OK. Now the problem is that I moved this object after I created this extrusion. So what I can do now is I can delete the extrusion and I can go back here. Whoa. Hit the drop down to object, zoom in. Looks like it still didn't work. Let's activate the entire assembly. Let's move this again. Now when I move it, I think what I need to do is select capture position right here. Go back to the foot. I am not sure. Why that doesn't update. We can worry about that later. Let's make a copy of this. Activate the entire assembly. Click on the foot, Control C, Control V. Come over here. We know we want to move this 18 inches minus the width, which is going to be 1 5/8. Boom, right there. What we are going to do though is we're just going to, instead of using, because I messed up with the position of this back one, instead of using to object, we're just going to say 18 inches like before. Negative 18, that is. All right, we're coming together here. Now you can see what our issue is going to be. This is our shaft, and our shaft needs to go into here and here. And it only measures 6 inches. So we need to put a hole in here and a hole in here, but it's going to be a blind hole, meaning it only goes to a certain depth. So let's open a sketch on this face. Activate the foot, open a sketch. Let's project. Select OK. Draw a circle. We know that the diameter of that shaft is 1 inch. So we'll put a 1 inch hole here. In reality, it needs to be just slightly larger so that the shaft can fit in and rotate freely. And then let's position this hole. So using our dimension tool, we want it to be positioned right in the middle, 0.75. And we also want it to be probably pretty close to this front edge, I would say. I'm going to say in the middle of this right here, which would mean that's 1 5/8. 1.625, and I can just say divided by 2. I like that right there. Now, extrude this. Let's cut this out. I'll do a depth of 1/4 inch, negative 0.25. Select OK. All right, there we go. We have a hole for our shaft to sit in. Now we are going to have a problem here with this copy that we created. So what we'll do next is let's activate foot number 2. Click on it, M to move it. Click on it again, and we need to rotate this 180 degrees. And we also need to move it downwards. Let's see, there it is. Let's get this sketch out of here. I don't like that. Where is that? Hide it. We can also assemble as we go along too, if we feel the need to do so. All right, we're looking good so far. However, our stance is way too wide. So we need to close this. 1/4 inch hole, 1/4 inch hole, 6 inches in length. So here's what we're going to do. We want the shaft to be positioned right in the middle. Okay, so we actually need to move there's a number of different ways in which you could do this. But let's join these two together, right where they are. And then we're going to move it over 6 inches. For accounting for the length of our shaft too, 5.5 between. This whole thing measures 9. If the shaft is in the center, you have 2.75 inches to this face. 2.75 inches from the center to this face, plus another 1.5 to here, 3.25. So 9 minus 3.25. This should be right. That should be right in the center. Might need to do some slight adjustment. Okay, now let's assemble this. Joint. That's exactly what we want right there. Okay, I think my math might have been slightly off. That's all right. Joint. Select OK. Let's see what we're looking like here. Yeah, off, definitely off. Okay, let's think about this. So this measures 8.75. Let's pull up our little calculator and do some math. 8.75 divided by 2 means that there are 4 3/8 from the center of the shaft to this face. And we know that it's 9 inches from this face to the center here. So the distance from this face to this face needs to be 9 minus 4.375, 4.625. Okay, let's do that. M, components, let's click here. Nope, we got to change our joint. Here's the first joint that we created. Right click, edit joint. And our number was 4.625. There we go. That's it right there. All right. The next thing we can create is our lever arm. So here's how we're going to do that. New component. Open a sketch on that face. Project so that this hole is included. Perfect. Extrude to create a new body. We know that we can go 3.5 inches with a 2x4. That's what we want. Right click, physical material, pine. There we go. All right, now 3.5 inch width, right? What's the distance between these two faces? Boom. Let's hide the lever for a second. Hold control, click here. 5.5. So this thing needs to move 1 inch to the right. And we can take care of that when we assemble it, like we're going to do right now. So go to motion. We're going to create a revolute joint here. Let's just hide the lever for a second. Actually, if we select the middle of the shaft here, we'll be golden. There's the middle of the shaft. Show the lever again. Okay, hover over this inside face, hold control. Now I should be able to select the center of the shaft, or the center of the hole, that is. There we go. Let's hit OK here. Boom, that looks good. Now you might actually find that you want to close this gap here in this gap here in an effort to prevent the arm from sliding left and right along the shaft. So if that's the case, let's see what the distance is between the two right now. We've got 1 inch. I want to tighten that up. I might make that only about 1/8 of an inch. Which means I'm going to move this an additional 4.625 plus 7/8. Oh no, I'm currently constrained by the depth of the hole, so I'm going to go Control Z on that. And I can make this hole deeper if I want. So I'll go back to my foot. Let's find the hole that I created. I went 1/4 inch deep. Let's think, if I go 1 inch deep, that'll leave 1/4 inch on each side. Let's go 1 inch deep here. Activate the whole assembly and see what that looks like. Yeah, now I only have 1/4 inch gap on each side. Here. And here. Or I should say, if I click here, hole control, go around 1/4 inch. That's perfect. What's not perfect here is I can go ahead and I can animate this, animate joint relationships. But if you think about it, it doesn't really make sense. We're going to have interference with this square end. So what we need to do is we need to add a fillet to it. So we are going to modify our lever here. Just with our initial sketch, let's open that. We can just modify the body afterwards, actually. Let's do that. Instead of a sketch fillet, we'll use a real fillet. Oh, not what we want. Let's see. I selected we want this edge and we want this edge. It's going to be 0.75. There we go. That makes a lot more sense now. Now this can rotate without interference. We'll worry about adding motion limits in the future. All right, this is a good start. We'll pick back up in another video.